The universe has a finite future, and physics already knows several ways it could arrive. We are ranking every way the universe could end, from the least likely to the most. Number 1 is not the loudest ending. It is the one the evidence keeps pointing toward. Number 10, the big snap. Space itself may not be infinitely stretchable. It could have a smallest possible size. In this fringe idea, expansion eventually pulls the fabric past its own granularity. Space-time would not tear open. It would simply stop being able to hold structure. Matter would come apart because the geometry underneath it no longer works. There is no accepted mechanism, no equation, and no observation supporting this. It sits at number 10 because it is a hunch about physics we do not yet have. Take it as a reminder that our theories of space still have gaps at the smallest scales. Number 9. Strange matter. Quark matter containing strange quarks might be more stable than ordinary matter. If true, a single fragment called a strangelet could convert whatever it touched. Contact would spread through a planet, then a star, converting matter as it went. Physicists reviewed this formally before switching on heavy ion colliders. Those reviews found no credible risk, and cosmic rays have run the experiment for eons. It is also local. A strangelet ends worlds, not a universe. Still, it remains one of the few endings that could begin with a single particle. Number 8, a bubble universe collision. Eternal inflation predicts our universe is one bubble among endlessly many. Other bubbles keep forming, and some expand toward ours at nearly light speed. A collision would arrive with no warning because the wall travels with the light. The impact would rewrite the laws of physics inside whatever it swept through. A 2025 study modeled the fingerprint such a collision would leave in the microwave sky. Nobody has found that fingerprint yet, which is why it sits at number 8. If it ever came, we would never get the chance to record it. Number 7, the big bounce. Some models say the universe does not end at all. It resets. In cyclic cosmology, expansion is followed by contraction, then a bounce into a new beginning. Roger Penrose proposed that a cold, empty universe simply becomes the next Big Bang. He and his colleagues claimed to find circular signatures in the microwave sky. Those claims remain contested, and mainstream analyses do not support them. It is a genuine research program, but the observations have not backed it yet. A bounce would not be an ending at all. It would be a handover. Number 6, the big rip. If dark energy grows stronger with time, expansion outruns every force holding things together. Physicists call this phantom energy, and its pressure parameter drops below -1. At -1.5, the rip could arrive in 22 billion years. Galaxy clusters shred first, then galaxies, then solar systems, then planets. Earth comes apart roughly half an hour before the end, and atoms in the final instant. Measurements put that parameter near -1, so the rip is allowed, but disfavored. Better dark energy data this decade will settle whether it stays on the table. Number 5, vacuum decay. The Higgs field may be sitting in a valley that is not the lowest one available. Measured Higgs and top quark masses place our vacuum squarely in the metastable region. One quantum fluctuation could nucleate a bubble of true vacuum anywhere, at any moment. That bubble would expand at light speed, so nothing could ever see it coming. Inside it, the constants of nature change and no atom can exist. Estimates put the weight at 10 to the power of 790 years. That is unimaginably longer than the universe has so far existed. Number 4, proton decay. Many grand unified theories predict that protons are not truly stable. Given enough time, every proton would dissolve into lighter particles and radiation. Every star, planet, and body would eventually thin into a faint haze. Super-Kamiokande has watched enormous tanks of ultra-pure water and seen nothing. Its limit now stands above 2 × 10 to the power of 34 years. Hyper-Kamiokande begins taking data soon and will push that limit 10 times further. Until then, nobody knows whether ordinary matter carries an expiry date. Number 3, everything evaporates. Hawking showed that black holes leak radiation and slowly shrink into nothing. Recent work argues that any object with strong enough gravity does the same. So, white dwarfs and neutron stars evaporate too, with no event horizon needed. Radboud University researchers put the last white dwarfs at 10 to the 78th year. The previous estimate had been 10 to the 1100th year. The universe's final structures vanish far sooner than anyone had assumed. Even black holes eventually finish the job, leaving nothing with structure behind. Number 2, the Big Crunch. For decades, the crunch looked dead because dark energy appeared to be constant. Then, DESI and the Dark Energy Survey found hints that it is weakening. The preference for evolving dark energy now sits between 3 and 4 sigma. Cornell's Henry Tye modeled it with an ultralight action and a negative cosmological constant. His result gives the universe a total lifespan of about 33 billion years. Expansion would peak in 11 billion years, then reverse into collapse. The signal is not yet strong enough for anyone to call it settled. And number 1, heat death. The most likely ending is also the quietest one. If dark energy really is constant, expansion never stops and never reverses. Stars burn out and galaxies drift beyond each other's horizons, one by one. Every remaining object evaporates until only cold, thin radiation is left. Entropy reaches its maximum and nothing can ever happen again. No explosion and no collapse, just an endless dark that never changes. It is the default fate, and every rival needs new physics to beat it. Which ending would you rank differently, and did any of these surprise you? Comment below, then subscribe.